a couple days ago.
Okay, did you email me it?
Yeah, I emailed you a picture.
2 days ago. That would make it.
It may have been over the weekend, actually.
What's it gonna show up under? Merrick?
Type in my name. Yeah.
Let me type in Merrick.
So is this a 30-minute or an hour session? I can't remember.
Oh, you got down as an hour, but you can do either one.
No, we'll just see how far we get.
Okay.
That's how we'll decide.
You know, it doesn't find that email. Let's see. Let's look at the calendar and figure out which day it was you sent it to me. Would it have been from your email address?
Yes.
Let me search for that. What's your email address?
MerrickWeaver@yahoo.com.
Here it is. It was November 4th.
So that was a little bit more than a couple days ago.
Yeah, not that much. Okay. Yeah, we didn't get through this whole thing.
We left off at 3. We're on 4 now.
We did 3. 3 was
Yeah, we did.
ellipses.
Mm-hmm.
Yeah, we did do 3. I remember that equation over there for the focal distance. Okay, let's do 4. Is that a 36 denominator?
Yeah.
Must be. All right. So, what is this? What
Mm,
figure?
that's an ellipse too, right?
Huh? Okay. When you encounter an ellipse, the very first thing you want to figure out is it a horizontal or a vertical? And this should be squared here, not cubed.
Yeah, I believe so.
Yeah. I wouldn't know what it was if it was cubed. Certainly nothing
Yeah.
we would be studying. But so the way you determine whether it's horizontal or vertical is by which variable the largest denominator is under.
Okay, so that'd be the left side, right?
In the first case, it was the 25 was under the y. That put the major axis on the y-axis.
So
Because
making it vertical.
that is A, the distance from the center to the major vertice.
Okay.
In 4, it's a horizontal ellipse because the measurement of A is measured horizontally. And the only reason you know which one is A is because A is always bigger than B. And if A is bigger than B, then A squared is bigger than B squared. Well, not always, actually. But yeah, A is always bigger than B with ellipses. Okay, so this
Okay.
one they want the same thing. What does this say? That means center, focal distance, focal distance.
It's focal points. It's center, focal distance, and focal points.
Okay, got it. So let's put a coordinate system on this ellipse that I just drew. Where's its center?
1.
No,
Yeah.
Let's go back, and the general formula for an ellipse is what? In other words, if you don't know the answer to this, you always have to start there.
Isn't it x minus k squared plus
H
y? No.
always goes with x, k
Oh, that's
always
right.
goes with y.
Okay. Makes sense.
And they're always minus.
Always minus.
Well, until you get to calculus. Once you get to calculus,
Well,
you encounter x plus h. But as long as you're not in calculus, it's always minus. And it's always equal to 1. Okay?
Okay.
Now, tell me what the four things you have to know are what h means, what k means, what a means, and what b means. So what's
Alrighty.
h and k mean?
H and k is negative, or h, first of all, is positive 2. K is positive 4.
Okay.
A is 36. Or no, A is 6, technically. And then B is 5.
Okay. Tell me what h and k mean. That's the center of the ellipse.
The center points?
Yep. The center of the ellipse.
Okay. So
Just like h and k were the center of the circle. H and K are the center of the ellipse.
So it's 2 and 4 is the center of the ellipse?
No, let's go back and figure out what H is again. If H was, like you said, 2, then that would have to read x minus 2.
Okay.
It doesn't. It reads x plus 2. Therefore, H is what?
H is, if it's plus 2, then wouldn't there be just like a,
Then
would it be
H
multiplied by like something?
negative 2. H has to be negative 2. Why? Because x minus a negative 2 would result in x plus 2. And it is x plus 2 that we're seeing, which means h is minus 2. H is the opposite sign of the number you're seeing there. So h is minus 2 and k is minus 4.
All right, that makes sense.
So if I go to graph that, and I go to minus 2, minus 4, we'll put it right there. And I know it's horizontal. So I can do a rough drawing of it. And now they want the focal distance. Okay, so let's see. First of all, we'll label everything over here. H is minus 2. K is minus 4. A is 6. B is 5. And there's one more important thing, C. What's the general equation for C?
I don't know that.
This one right there. Oh, actually,
Okay.
let me teach you a better way to remember it. C squared equals A squared minus B squared. And the reason that's a good way to remember it is because it's very similar to the Pythagorean theorem. The Pythagorean theorem is C squared equals A squared plus B squared. Well, the only difference is change the sign. It's A squared minus B squared, which makes C, the focal distance, what they're labeling F sub D, I call C, that is going to be the square root of A squared minus B squared. Notice that's exactly what that reads also. And
Okay.
so, what is C?
So is C the square root of 36 squared minus 25 squared?
Well, it's the square root of 6 squared. In other words, it's the square root of 36 minus 25.
Okay, my bad.
Okay, so that's the square root of 11. And that's what C is. Now, let's go back to our drawing and start labeling some of these things. I'm going to label these points up here. Here's the center. That's minus 2, minus 4. There's two focal points. One is somewhere approximately there. The other is the same distance on the other side of the center there. Let's label those. Remember what C is. C is the distance from the center to the focal point. So this distance right here.
Okay, that's on you. What is that distance? Is it?
What is it? It's only along the x-coordinate, right? The y-coordinate's not going to change. The y-coordinate's going to be the same. They're all on a horizontal line. So it's only the x-coordinate that changes. How much to the right of minus 2 are we going to be?
Much to the right.
Square root of 11. That's what C is.
Square root. Okay.
Okay.
Is that like the distance between the two?
Here's how we label this point. We're not going to label it the way you think. We're not going to convert that to a decimal and add it to negative 2. We're going to label it like this. It's minus 2 plus root 11. That's the x-coordinate of the focus. And the y-coordinate is still minus 4. We didn't go up and down. We just went left and right. With me? Now let's label the other focus. What's that going to be?
Would that be negative 2, negative 4 plus
now, hold on.
Square root of 11?
No, the square root of 11 goes with the x-coordinate.
Okay.
Okay, so it's negative 2 minus square root of 11 because it's going in the other direction, right? In other words, if that's negative 2 there, then that's negative 2. That's negative 2 minus. That's to the left of negative 2. So that's the x-coordinate, and the y-coordinate is still minus 4. Now, this might be something you're not used to seeing, where your x-coordinate is a binomial thing, rational number combined with an irrational number. Like over here, that is the proper way to write that. And I don't know if you've seen it like that before. Okay. When you're dealing with conic sections, get used to seeing it like that. Okay. Now, have we answered everything they wanted?
Yes.
Both focal points and the focal distance. What's this ORAL? Oh,
Where?
CAL, focal. Okay. Okay, now, they didn't ask you about the vertexes. There's a vertex there, there's a vertex there, there's a vertex there, and there's a vertex there. If I truly wanted to know everything there was about this ellipse, I would want those 4 points also.
Okay.
Particularly if I'm graphing it. And that one says do not graph. This one we're supposed to graph. And you cannot really graph it if you don't know these distances. Well, these distances are pretty easy. If the center is at minus 2, minus 4, and A is 6, then what is that coordinate right there? that major vertex.
I think your screen froze or something. Yeah, now it's better.
So it switched back.
Yeah.
And now you're looking at my email
Yeah.
page.
I am.
Okay, it might have been that screenshot that was acting up. Let me try that again. Okay, so anyway, the center was at -2, -4, and that right vertex was 6 points to the right of the center. So what is that right vertex going to be?
6 points to the right of the center.
Yeah, here was the center.
Okay. Yeah.
And the right major vertex, A was 6. A is 6 based on that. So
Okay.
what are the coordinates of this right vertex?
It would be 4,
Correct.
2.
No, the y doesn't change.
Okay.
Remember, we're on a horizontal ellipse. The center, the y coordinate's the same as the focus is, and it's the same as these vertices. So always keep that in mind, because they're going to give you problems that are harder where you have to kind of know this. And when you're looking at the minor vertex, which is B, in other words, the distance from the center to the minor is B, the only thing that changes is the y coordinate. All three of these x coordinates are the same.
Okay.
Okay? All right, let's go on. I'm amazed they didn't ask you that, but they didn't. So hold on, let me graph that up. All right, now we're getting into a little harder ones here. The reason this is harder, because they didn't give it to you in standard format. In other words, if I look at 6, clearly 6 is in standard format.
Yeah.
6 is easy. We can figure out what A is. A is going to be 4. B is going to be 3. We know the center's at -3, -4. And this is a hyperbola because of that. I'm not ignoring 5. We're going to get back to 5. But I didn't realize you had gotten to hyperbolas yet. Also, hyperbolas are the hardest of the 4. They're a lot like ellipses.
Okay.
I still think they're the hardest of the 4, but they're not that much harder than an ellipse. They're harder to graph because you have to graph an imaginary rectangle in the middle for starters. Let's get back to 5. Hyperbolas are we need almost a full session to cover hyperbolas. And both 6 and 7 are hyperbolas. Now, notice that 7 has a plus sign there, but it's got a minus sign there. So if I switch these two things around, they're being subtracted. Whenever you have the two things being subtracted, that's a hyperbola. When they're being added, it's an ellipse. Okay?
Okay.
Let's get back to 5. Because 5 is given to you as a standard polynomial in standard form. It's not given to you in standard conic section form. So we have to do that. We have to put it in standard form in order to be able to graph it. Why does it say do not graph?
What is finding the focal distance and the focal points?
Well, you can't find those without putting it into standard format.
Yeah.
Now, can you tell me by looking at this polynomial whether it's an ellipse, a circle, or a hyperbola?
It's not an ellipse, I believe.
Well, first of all, let's check if it's a circle. If it's a circle, the coefficient of the x squared and the y squared are the same. That makes it a circle. If they're being added. Okay? And that right there means they're being added.
Yeah.
The y squared is being added to the x squared term. That makes it, if they're the same, that would make it a circle. If they're different numbers, it makes it an ellipse. So this is an ellipse, okay? And if this was a minus sign in front of either the x squared or the y squared, one only, then it's a hyperbola. So we're dealing with an ellipse. That's for starters. And now what we want to do is complete the square. Okay? Much like we had to complete the square of a quadratic in order to put it in vertex format, you have to complete the square on all four of these things in order to put it into standard format so that you can figure out what all these things are. Okay, how do I complete the square?
We have to. Don't we make both parentheses? We have to make a. Do we?
Kind of,
over here.
Here's the way to describe it. You have to combine the x terms. You have to combine the y terms with parentheses. And complete the square within the parentheses.
Okay.
So the first thing I'm going to do is combine the x terms and put parentheses around them and leave room to complete the square. That's why I left that big gap. Okay? Now they're being added, and I want to put parentheses around the y terms also. So it's 2y squared plus 4y, leave some room, equals 7. The key being I have not changed it. I've not changed it a bit. Just put parentheses around and gathered like terms. They won't always necessarily be in order either. They might put the x term way over here on the right. So the key is to gather the x terms together and gather the y terms together. Now, complete the square on the x terms.
All right, so we take half of the middle term and square, right?
Half the middle term's coefficient. In other words, you're not taking half of 6x. You're taking half of negative 6.
Yeah.
And so
okay, and then we get negative 3 squared, which is 9.
Okay, so, and you're always adding. When you complete the square, you're never subtracting because even a negative number squared is positive. And if it's a positive number squared, it would still be positive. So I'm adding 9. Now I just changed something. What do I have to do to the right side of the equation?
Add 9.
Correct. Because it's on the other side of the equation. If it's on the same side of the equation, you subtract 9. But this is on the other side of the equation. Now, to complete the square on the y stuff, what do I got to do? I can't complete the square right away. There's something wrong. What is it?
The 2.
Okay, what do I got to do?
Do we move it over?
You got to factor it out. In other words, we have to factor it out so that we have this. Now leave room. Now I can complete the square inside the parentheses. The only time you can ever complete the square is if that coefficient on the squared term is 1. And it is now. So now complete the square.
All right, so we take 2, 1, which is, it's just 1, plus 1.
Okay, now when I write that plus 1 in there, how much did I add to the left side of the equation?
1.
No, that 1 is being multiplied by 2.
So 2.
So I got to balance it with a 2 on the other side. Okay, that's very important. You always have to multiply that by what number you wrote in there to figure out how much you added to the left side of the equation. You didn't add 1, you added 2. Okay, now each term can be written in standard format. How do I write that in standard format? Or not in standard format, in other words, this kind of format. X minus h squared. How do I write that as an x plus or minus h squared?
We have to take everything out of the middle pretty much.
Hold on. It's real easy. Whatever you got when you took half, that's what it is.
Okay.
That's it. It's that simple. Okay?
Alrighty.
Now, do the y for me.
Would we solve it out, or is it just the equation?
You're trying to represent that in this format, y minus k squared.
So it'd be y minus 2, or my y minus 1, I mean.
It's not minus. There's a plus sign.
Or plus.
Yeah. So it's y plus 1. And the 2 is still there, hasn't gone anywhere. Add up all the numbers on the other side, I get 18.
Yeah.
Okay? Now, this part's a little tricky. Remember the standard format is this thing has to equal 1. So what do I do now?
Would we...
This is always the same step. Whenever that number is not 1, you always do exactly the same thing, which is to divide both sides by that number. Notice if I divide both sides by 18, I'm going to turn that 18 into a 1.
Okay.
With
that
me?
Makes sense.
Okay, so here's now what we have. We have x minus 3 squared over 18 plus, that becomes a 1/9. So we have y plus 1 squared over 9 equals 1. Perfect. We got everything we need. Except I needed parentheses there. Okay, now we can answer our questions. What's the center?
The center is positive 3, negative 1.
Good. What is the A, B, and C? Because you need A and B before you can figure out C. And you can't figure out focal distance and focal points without C. So, what's A? First of all, I guess we really don't need to know that. Yes, we do. It says do not graph. When it says give the focal points, does it want the coordinates?
Yeah.
Okay. then we do need to know whether it's horizontal or vertical. What is it?
It's horizontal.
Correct. And what is A?
A is 18, with the square root of 18.
Square root of 18. The square root of 18 is the square root of 9 times square root of 2, so it's 3 root 2.
Okay.
Okay. What is B?
B is 3.
Okay. What's the formula that relates C to A and B?
Relates C to A and B.
It's
Focal distance.
like the Pythagorean theorem, only a little different.
C equals A squared plus B squared or minus B squared.
A squared minus B squared. If it was A squared plus B squared, that'd be exactly like the Pythagorean theorem. And on hyperbolas, which we haven't got to yet, but you have 6 and 7 are both hyperbolas, that's what it is. It's A squared plus B squared for hyperbolas. Believe it or not,
Okay.
the formula for C changes. Okay? Hyperbolas are more complicated. We might not even be able to get to them tonight. Or we might. As soon as we finish this one, we'll take a look at C, or 6 rather.
What kind of openings do you have tomorrow?
Not very many. My Tuesday through Thursdays are virtually fully booked from 3 to 9 by Monday. By Monday, they are fully booked from 3 to 9. That's what happened this week, was that Monday morning they came out of the woodworks and I ended up getting full. So unless you can do it outside of the hours 3 to 9, you can do it in the morning. I got plenty of time.
Okay.
Or if you can do it in the lunch hour. Any time except 3 to 9. And Friday I got lots of times. So do I got Saturday and Sunday. So and it's going to be like this for the next 5 weeks, Merrick. It's going to, except Thanksgiving week. Thanksgiving week it won't be crowded, but as you go into finals, semester finals, it's going to be like this. So,
all right.
Get back to C. We haven't solved for C yet. If C squared is that, then C is the square root of that. Okay? So what is C? The square root of what?
So C is the square root of 18 minus 9.
Yeah, we didn't do ourselves any favor by simplifying that, because what we needed was that squared. So we should have just left it as square root of 18.
So C is just 3 then, right?
Uh-huh. And yeah, so that's 9. So C, oh, something's wrong. No. No, I guess that can be right. I never have seen a C that's the same length as B. But I guess there's nothing wrong with it. C has to be smaller than A, because on the ellipse, if we draw the ellipse, this distance is A, and C is somewhere from here to here. So C is always smaller than A, but I suppose since that is B, C could be equal to B without messing anything up. First I thought we must have done the math wrong, but no, 3 is right for C. So in our graph, now we're ready to give the focal distance, which is 3, and tell me what the focal points are.
So the focal distance, so the center is 3, -1, right?
Now, hold
And
on.
then,
Let's write the center. The center is, 3, -1. Okay. And the focal distance is 3. And it's horizontally oriented. So what's the
okay,
right focal point? This one that I've got labeled here.
that would be 6, -1.
Okay. And what's the left one?
It'd be 3, 2.
Remember, only the x-coordinate changes. When you're on that major horizontal axis, the y-coordinates are always the same. So it's definitely a -1. The only coordinate that's changing is the 3. What's the distance
Okay,
to the left focal point?
3, right?
Or what's the coordinate of the left focal point?
0, -1.
Uh, so those are your focal points right there.
Okay.
Do not graph. Why would they say that? That's just not part of the thing, huh?
Yeah.
I guess they don't want to focus on those vertice measurements. Because
Yeah.
to graph it, you need to know those 4 points right there also. Okay. Let's... Want to go on to hyperbolas tonight?
We can get it as far as we can. Yeah.
Let's do
On
it.
it.
First place to start is the general format. I'm going to write think be better off if I do it this way. A little more writing room. As with the ellipse, there are 2 different ones. Depending on whether the ellipse was vertical or horizontal, it mattered where the larger denominator was. Well, a hyperbola is not like that. A hyperbola has 2 different formats. They all have this in common. Only it's being subtracted instead of addition taking place. Still equal to 1. So it looks almost exactly like the format for an ellipse, only the subtraction sign instead of the addition sign. The
Okay.
other format is this one, where the y is in front with the a under it, and it's the x that's being subtracted. Excuse me, I want that, I want it like this. Now, if it is the first format, it's a horizontal ellipse, kind of like, it's a horizontal hyperbola. Horizontal hyperbola would look like those curved lines there. Okay? If it is like the second one, if it's y squared minus x squared, then it is a vertical hyperbola. It's going to look like this. So much like an ellipse, the first task you have is to figure out which it is. Okay? Now, let's talk about how we draw a hyperbola. Well, let's go back a second. Look at those graphs. A is always measured along the major transverse axis. That is the major axis. The axis that goes through the center and both vertexes. This one only has a vertex here and a vertex there. Okay? So this is always A, the distance from the center to that vertex.
Okay.
The focal point is always inside the ellipse, and C is the distance from the center to the focal point. So C is always greater than A with an ellipse. Or, excuse me, I keep saying ellipse, I mean hyperbola. So what is B? Well, let's look at the second one here. In other words, the one that goes with the second general format.
Okay.
A is measured vertically. That's why it goes with the y term. It's this distance. With me? In other words, A is always measured along the major transverse axis. In the bottom one, the major transverse axis is the y-axis. That's the axis. We have a vertical line that goes through both vertexes and the center of the hyperbola. So first of all, that's what where A is measured. And that's why in the horizontal hyperbola, A is under the x squared term. In the vertical hyperbola, A is under the y squared term. Now let's talk about B. I guess I can do it. The way you construct a hyperbola is by starting with an imaginary box. And these hyperbolas that I've drawn here are at the origin. Makes it easier to talk about them. They don't have to be at the origin. In other words, if there's a K and an H, then they're not at the origin. But the way I've drawn it here, the center is at the origin. Okay? And that's A, and B would be this distance. Now, why the imaginary box? Because the next step is to draw the imaginary by imaginary. You don't actually draw this when you're graphing the ellipse or the hyperbola. The purpose of these diagonals is the hyperbola is asymptotic to those diagonals. So that's really the way to draw the hyperbola. Let me draw it in a different ink. Now that I've got the proper grid, I'll draw it in green, and really that hyperbola is asymptotic to that diagonal. It means it gets closer and closer and closer to it, never touches it. Same way on the other side. It just gets closer and closer and closer. And the vertex of the hyperbola is at that midpoint of that box. Same thing on the upper side. Something like that. Okay? So that's what B is. B is the measurement of this imaginary box that you don't even see. In other words, the final graph of this hyperbola are just the green lines. You don't put the box in there, and you don't put the diagonals in there. But if you want a reasonable graph, you've got to do that. And it's important to know what B is. And finally, you need to know where the focuses are. The focal points are at C.
All right.
Okay, and with the hyperbola, it's exactly the Pythagorean theorem. It's this.
Okay.
Opposed to with an ellipse, it's a squared minus b squared. The fact that c squared is a squared plus b squared means that a and b can be anything relative to one another. A does not have to be bigger than b. The shape of this box can be a square, it can be a horizontal rectangle, or it can be a vertical rectangle. In other words, A can be bigger than B or less than B. Nonetheless, C is the square root of A squared plus B squared. So you still got to figure out A and B to figure out C, and C is still the magic number because that tells you where the focal points are. And the focal points are the important parts of all of these things. Whether it's a parabola, an ellipse, or a hyperbola, the focal points are the most important thing. So you always have to figure out C. All right. So that is Hyperbolas 101. We got 10 minutes. Let's go back.
We'll just stop there for right now.
Okay.
Because I have the basic formula.
It really is a lot to memorize.
Yeah.
Key thing to memorize are these general formulas. That is always has to be your starting spot with these conic sections. If you don't start there, you got no chance. You got to start there, and you got to know what HK, A, and B are, and how to figure out C. All right, Merrick.
Thank you.
I will talk to you at your next session.
All right. Thank you. Bye.